Good evening, students. Ninth class first chapter name is real numbers. In the previous video we completed one subtopic, that is 1.1, which is called as an introduction. In that introduction we discussed about rational numbers. Now today second subtopic, that is 1.2. Its name is irrational numbers. Actually this is the main topic for 9th class students. Previous however 8th class there. That's why it is very important for 9th class students. So in 1.2 title name is irrational number. In that we made 4 parts. Among that four parts I want to discuss. One part is A, one part is B, one part is C, one part D. Based on this A, B, C D, we can close this title. So let us see first part, that is A. What is A? Irrational numbers. So carefully observe. See, this setting once observe. What is actually setting is, let us go with one by one. To reach the irrational numbers, first we have to discuss Roman number 1, Roman number 2. Why we want to discuss? Let us see one by one. See, first let us go with first Roman number, that is non-terminating, non-repeating decimals. In this, here what is this D? Nothing but decimals. I want to make 2 parts. Mainly I want to make decimals 2 parts. One is 0.5. One more is 0.2 bar. I want to give one more example is 0.01. I think understood. 001, 0001, dot. Students be at least. This is the terminating decimal. We can call as TD. TD in essence terminating decimal. These two are examples of non-terminating decimal. Simple. These two are non-terminating decimals. This is terminating decimals. I think understood. And mainly this NTD, non-terminating decimals. These non-terminating decimals again we make 2 parts. See, this what happened? Repetition is going on. 2 is repeated many times. That's why its name is 0.2 bar. Then it is one side 0.01, 001, 0001. This is another side. Mean here 2 examples are given, which are called as the non-terminating decimals. These 2 examples I made 2 parts. In these 2 examples, once carefully observe. Here repeated 2, but there is no repetition. So based on that, its name is NTRD, nothing but non-terminating repeating decimal. A repetition is going on, that's why its name is non-terminating repeating decimal. But here what happened? Any repetition there? No. So its name is non-terminating, non-repeating decimal. I think you got clear picture. Here I took non-terminating decimals are 2 types. I took here 2 figures. These 2 figures are separated 2 parts. This is one of the NTRD because of 2 is repeated. Here there is no such a repetition. That's why this is called non-terminating, non-repeating decimal. This is called non-terminating repeating decimal. we are expecting non-terminating, non-repeating decimals. Where are they? Non-terminating, non-repeating decimals. Is it non-terminating, non-repeating decimal? No. Is it non-terminating, non-repeating decimal? No. In a sense, our content here, our concept here, this is best example for non-terminating, non-repeating decimal. I want to give few more examples there. 0.12, 112, 1112, dot dot dot. This is what? Same non-terminating, non-repeating decimal only. One more example, 0.34, 334, 3334, dot dot dot. Like this, we can write many which are called as non-terminating, non-repeating decimals. I think you got it clear. This is what about Roman number 1. Okay, now can I give short conclusion about this? Once. Non-terminating, non-repeating decimal is my main concept. Just I made two parts. One side I wrote terminating decimal. One side I wrote non-terminating decimals. This non-terminating decimal side I gave two examples. These two examples I divided two parts. In a sense, here repetition is going on. There is no repetition. Based on that, its name is non-terminating repeating decimal. Its name is non-terminating non-repeating decimals. But my topic is non-terminating non-repeating decimals. So that these are considered to engage my chapter. Okay? Understood now? Right. Let us see. Okay, right. Next is second Roman number 1 subject. What is second Roman number? Surds. What is actually surd? Surd is nothing but the number which is written in the form of nth root a. The numbers which are in the form of nth root a, where n value is greater than 1, it belongs to natural. First condition. Second condition, inside a there no, this should be positive rational number. That is second condition. Third condition is a cannot be expressed as nth power. We cannot express as a nth power. Number which is following these three cases, three conditions, that is called as surd. Once again, pay attention carefully. Nth root of a. Nth root of a is called surd. Once again, nth root of a is called surd. But based on these three cases, these three conditions compulsory. If any condition is failure in that, that is not called as a surd. I think understood. For example, example sides once we will discuss. N value is greater than 1. It is a natural. For example, n value take 2. Now second root. This is what tell you. We are talking about first condition. N value is more than 1. It is must be natural. That's why can I take 2? Yes, we can. Next, we can take the root, cube root also. We can take fourth root also. We can take fifth root also. We are discussing about first condition. It is clear. Now these are based on the first condition. Let us go with the second condition that age belongs to positive rational. Positive rational in the sense, you take here 2. 2 is positive rational number or not? Let us take here 1 by 2. It is also positive rational number or not? Let us take here 9. It is also positive rational number. Here take 5. It is also positive rational number. We discussed about second condition. Now what about third condition? That is A. Here 2, here 1 by 2, here 9, here 5. In A position, whatever the number, it cannot be expressed as a nth power. In a sense, carefully observe. Nth root of A there no? it cannot be written nth root of a to the power of n. You cannot express in such a way. For example, now square root of 4 there suppose. Now tell me, is it surd? No. Why? Because square root of 4 can be written as 2 power 2. What happened? Exponent to n position, both are same there. So we can cancel. Now our result is 2, which is called as a rational. It is rational, but we need irrational. Nothing but we need surd. We need irrational. We are getting rational number. So that reason, square root of 4 is not a surd. One more example I want to give. Cube root of 27 there. Okay, now understand. Cube root of 27 there. Cube root of 27 can be written as 3 power 3. 3 power 3, however, 27. So, n position 3 there, exponent 3 there. So, both are however cancelled, we can get 3 only. So, what I am saying, n value more than 1, it is a natural. Yes, 2 is more than 1, natural. 3 is more than 1, natural. 4 is more than 1, natural. 5 is more than 1, natural. First condition is clear. Let us go with the second condition, that inside figure, nothing but a position should be positive rational. Yes, 2 is positive rational, 1 by 2 is positive rational, 9 is positive rational, 5 is positive rational. In such a way you take a position is a positive rational number. Let us go with third condition, that a cannot be expressed with the nth power. In a sense, like this you cannot express. Nth root of a cannot be expressed in the form of nth root of a to the power of n. Should not express in such a way. If you express such a way, what will happen? See, now these are 2 examples. We never get surds. See, square root of 4 answer direct 2. Is it surd? No, it is rational. Now cube root of 27. Its answer is 3. Is it surd? No, it is rational. Mean, if nth root of a can be written in the form of nth root of a to the power of n, we cannot make surds. So that reason, nth root of a cannot be expressed in the form of nth root of a to the power of n. That is the point third. In a sense, careful reason. Third, nothing but the number which are expressed in nth root of a based on these 3 conditions are known as surds. Now I wrote this is surd, this is surd, this is also surd, this is also surd. This is not a surd. This is also not a surd. Now come to the point. Now non-terminating, non-recurring decimals we discussed. Next, surds also we discussed. Now actually what is that? See, okay, right. I think understood now. Now I want to give brief and clear examples of this side, that side once. I want to mix all numbers together, see now. Now example side, I want to discuss mainly examples. What are the examples? See, 0.0101 001 0001 dot dot dot. Now root 2, next cube root 3, next fourth root 2, like this. Next 0.110 1110 1110, like this. Next cube root of 2, next cube root of 5, like this, etc. We can write many examples. But in this example, see carefully. What is this tell me? I want to round up which are called as a non-terminating, non-repeating decimals. This is non-terminating, non-repeating decimal. This is non-terminating, non-repeating decimal. Now remaining there, no, this one, this one, this one, this. These are called surds. Mean, when non-terminating, non-repeating decimals and surds are together, are known as irrationals. I think you got it. Carefully observe. What are the irrational numbers? Irrational numbers nothing but the combination of non-terminating, non-repeating decimals and surds are known as irrational numbers. Irrational numbers are denoted with Q complement. Remind carefully. last and final, the union of non-terminating, non-repeating decimals and surds are known as irrational numbers. Okay, na? Right? Okay. Okay, right? Students, next I told in the beginning only I told under the title of 1.2 irrational number topic there are I made 4 points. One is A, it was completed. Now second is B, again C, D there. Now let us see B. What is B? Nth root of A, where n value 2 in this position is 2. Next A value which is inside, that should be non-square numbers. These are called non-square numbers. I think okay na? These are called non-square numbers. Suppose 4 there. 4 is a square number. That's why I did not write. I need just non-square numbers, nothing but. I won't take 9 also. I won't take their 16 also. Why? Because those are called square numbers. But I mentioned there non-square numbers in the sense except these are called non-square values. Those are required in the position of A. Okay, na? So let us see one by one. We can list out the numbers. N value however permanent only, n value 2. Okay. A value let us take 2. This round also. N value 2, A value 2. Then what is figure? Nth root of A now. Second root of 2. Nothing but a shortcut, square root of 2. I think got it. Next to n value let us take 2 only, permanent this. A value let us take 3. You know, this is 3. Now what is next? Nth root of A. Nothing but square root of 3. Then we got square root 3. Here 2 there outside, but we won't write there. Remind that. Here 2 figure there, now we cannot mention there. Got it? This both meaning same only. We can call it is the square root, second root. It is also square root, second root. But inside here in this position we cannot write 2. If n is equal to 3, suppose n value 2, A value 3, 3 already over 4. Then what will happen? Nth root of A. Now square root of 4. So 4 is not well. 4 not 5. Why? Because 5 is the non-square number. No, let us take that one. So 5. Now this can be written as square root of 5. Last one. I think you got it very clear. N value 2. A value let us take next square non-square number, that is 6. Now substituting that. Now square root of 6, that means square root of 6. In such a way we can get many. For example, same manner we can get root 7 also, root 8 also, root 10 also, root 11, root 12, root 13. I think got it. Next root 14, root 15, square root of 17, square root of 18, square root of 19, now square root of 20, in such that we can write many. How many are there? Infinity are there. See, these are called as surds. However, surds only, no? These are called surds only, no? Recently we discussed, no? But every moment observe everything. Square surds. Inside 2 there, 2 there, 2, 2, 2, 2. Because of we took permanent n position is 2, that's why these are called square roots. These are called surds. Now in these surds, carefully observe, we want to discuss one point, that Roman number 1, history. One more side we want to discuss as the Roman number 2, values. How to find their values. Mean this is the network based on this condition. Out to make nth root of a values where n is equal to 2, a is non-square numbers. Non-square numbers. We got such a figures now. Root 2 there, root 3, root 5, root 6, root 7, root 8, root 9, 10, sorry. Square root 11, square root 12, 13, square root 14, square root 15, square root 17, square root 18, square root 19, square root 20. Like that we can make many based on this condition. Next topic, we want to discuss two concepts. One is history. One more is values of the particular figures. Let us go with history. In first point I want to discuss about root 2. Only root 2 I want to discuss. I think understood. Root 2 is one of the irrational number, but in 5th century BC, the Pythagoreans was first to introduce this. They introduced as well as they proved this. What they proved? They proved that it is an irrational number. And one more thing, the Pythagoreans says that first they said that they found that the numbers which are we unable to express in the form of p by q. In a sense, Pythagoreans, they found first irrational numbers. After that, they concentrate about root 2. They told very clear that root 2 is one of the irrational number, as well as they proved also first. You got it. After, I want to discuss one more point. Root 3 there, root 5 there, root 6, root 7, 8, no, direct to 10, root 11, root 12, root 13, square root of 14, square root of 15, square root of 17. Up to these, carefully, here which are missed? Root 7 is missed, root 8, these two figures are missed. In a sense, root 3, root 5, root 6, root 10, root 11, root 12, root 13, square root 14, square root 15, till square root 7. Those values are proved by Theodorus, Theodorus, is a famous mathematician from Greek country. Theodorus, he was said that these are also irrationals. As well as he proved. And one more point, one more important thing I want to announce that. 800 BC, there was one book. That book name is Sulabha Sutra. Sulabha Sutra. In this book, we are going to observe the irrational number concepts. When we are studying about the square roots of the calculation of the square roots. When we are doing the calculation of the square roots, we found that irrational concepts in Sulabha Sutra 800 BC. This is a small history about irrational numbers. Shortly, square root 2 then. This value proved by Pythagoreans from Greek country. And the Pythagoreans was told that first they found the irrational numbers which are we unable to return in p by q form values. Second thing, except to root 7, root 8, in a sense, root 3, root 5 to root 17. These 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These 10 values also called a irrational number. This point is said by Theodorus from Greek country. Third point, whenever we are studying in that book, mainly the book name is Sulabha Sutra, it was 800 BC. In that, irrational concept is available when we are calculating to find the square roots. I think got it. This is the little bit history about this concept. Right, okay. Next, Roman number 2 said once observe values of just now we discussed values of root 2, root 3, root 5, root 6, root 7, root 8, root 10, root 11, next root 12, root 13, root 14, root 15, root 16 order, 17, dot. These are our targets. These are our tasks. So let us see how to find the root 2 value, root 3 value, root 5 value, root 6 value, root 7, root 8, root 9, root 10, 10, 11, root 12, 13, 14, 15, 17, in such a way. I want to clear cut one or two problems. Based on that, we can find the remaining all. So let us see one by one. Value of root 2, let us see. So what to do in this process? Let us take 2. 2 is our number now. After 2, just put dot. Carefully. After dot, nothing there. Single digit, no? So after that number, after the digit, you just put dot symbol. Now you take as many zeros as your wish. Your wish. Okay. Dot. Next. But to do this one, this is called division method beta. This is what? Division method only. But to find the value of root 2, we want to use square table. What is the table? Square table. What is square table? See, I am writing. 1 into 1, 1. 2 into 2, 4. 3 into 3, 9. 4 into 4, 16. 5 into 5, 25. Like this. This is what generally we can call as a square table. This table is very useful to find the value of root 2 by the division method. Let us see one by one. Here 2 there. So which is convenient square table in this? 2 2s are 4, but 4 is more than 2. So let us take 1. 1 nothing but 1 1 za, nothing but here 1, here 1. 1 1 za 1. Now let us make minus symbol over there. Now 2 minus 1 how much? 2 minus 1. 2 minus 1. 1. Next here dot there. No, this dot you carry forward there. You write there, that's it. Now immediately take 2 zeros at a time. 2 zeros at a time. See, I took 2 zeros at a time. Then here 1 there, no. You add another 1. Then go for addition. Now 1 plus 1 is 2. Now very important thing. Here we need 1 digit. Same digit we want to write there. These 2 places, the digits should be same. In such a way, you search which is suitable, which is the nearest to 100. For example, if I am taking 4, same 4 should be there. Then what happened? Here figure is became 24. Here just 4. Now 4 into 24, how much? 4 into 24, how much? 96 only, no? See, 4 4s are 16, 1 carry. 4 2s are 8, 8 plus 1 9. Again minus. Now what is next? Here 4. Now here is 4 only. 100 minus 96 is 4 only, no? Remaining is nothing there. Next what to do? Take 2 more zeros. Now I took 2 more zeros. Then here 4 there, no? 4 should be added to 24. then what will happen? Tell me. It will become 28. Next, same root, repeat, same thing. Here you choose one digit, that digit should be required same. This digit should be same. So, and which is the nearest to 400. For example, if I am taking here 1, you replace here 1. See, 281 ones are 281. Suppose if you are taking year 2, then what will happen? Tell me. It is 282 into, then however 2 no. See, 2 2s are 4, 2 8s are 16, 1 carry, 2 2s are 4 plus 5. This figure is more than 400. So that's why carefully, be careful whenever you are doing the problem. So 1 is better one, correct one, So 1 into 281. In a sense, 281 ones are 281. Right? Minus. So what is next to year 9, year 1, however year 1. Same, again same work. Here what to do? Here 2 more zeros you carry forward here, like this you carry 2 more zeros. Here however we carry 2 zeros. I think understood no? Here 1 there no? You add 1 more 1, 281. Then it is became 282. Next what to do? Same repetition only. Here we need 1 digit. Same digit we have to replace there. For example, if I am taking 4, let us take here also 4. Once 2824 4s are once check. Now I am checking. 2824 into 4. Why? Because we want to reach nearest to this figure, not more than that. Nearest we are expecting. 4 4s are 16, 1 carry. 4 2s are 8 plus 1 9. 4 8s are 32, 3. 4 2s are 8, 8 plus 3 11. So what about this? Yes, it is very nearest to that. So 4 is a sufficient figure. So 2824 4s are, what is figure? 11,296. Next minus. Yes, in this manner, in this process, we can bring the results by using the square table. We can going to find in such a way the values of this all, not only root 2, just this is the calculation part, how to overcome the value of root 2. Now tell me, now I am erasing this square table, till we got up to here only, no? Mean after that we got up to 3 digits, nothing but now I am writing there, square root 2, answer is 1.414, again something will be there, so we cannot end that, we cannot stop that. And one more reminder that it is irrational number, no? These we cannot put a bar symbol also, nothing but we cannot see bar. Mean there is no repetition, simple thing. In this answer we cannot see the repetition because of it is irrational number. So this is one of the big number. We cannot express this number in P by Q form because of it is irrational. In a such a process, in this manner, in this process, we found the root value. See, my important note is that square root value approximately, this is the symbol of approximately 1.414 up to 3 decimal places. Up to 3 decimal places. I think you got it clearly understood. Similarly, we can find root 3, root 5, root 6, root 7, root 8, root 10, root 11, root 12, 13, root 14, root 15, root 17, whatever that. In this process, we can overcome that all values. Further, I think there is no doubt at all. Next, tomorrow class, nothing but next video we want to discuss that subtopics are C and D. C is nothing but about 5 symbol. Further details. Next, in D concept, we want to discuss that how to represent irrationals on the number line. I think got it. I am talking about tomorrow video, tomorrow class. In tomorrow class, we will discuss C and D topics. C indicates that about 5 symbol. Next one is how to represent these numbers on the number line. I think got it. I think everybody understood without any doubts. So dear students, small request. If you have any doubt, your doubts, comment in, share in the comment box. And one more important thing, that is a request also. Just you share my videos to others. You like it, and subscribe the channel. If you subscribe once, my videos automatic reach to you with notifications from my side. Thank you. Thank you so much.